Hello everyone, how are you doing? Welcome to a series on using the quotient rule for differentiation. So at the top we've written that if y equals u over v, where u and v are both functions of x, then dy dx is v multiplied by du dx, take away u multiplied by dv dx, all divided by v squared. So let's look at what this looks like in practice. So we've got the function y equals x plus 5 over x minus 3. Just as a side note, if you have been watching my videos on the product rule, you are able to solve this using the product rule, but the purpose of this video is to show us how to use the quotient rule. So we can let u equal the numerator, x plus 5, and we let v equal x minus 3, that's the denominator. Then du dx is equal to 1, and dv dx is also equal to 1. So now we have that, let's change the color, dy dx equals the quotient rule, which I'd recommend writing out with every question you do as you're practicing. So we've got v, which is x minus 3, multiplied by du dx, take away u, which is x plus 5, multiplied by dv dx, which is 1, and let that all be divided by v squared. So that's x minus 3 squared. Now at this stage, the function is differentiated, but for the sake of practicing our simplification, let's take this a little bit further. So we have x minus 3 take away x plus 5 all over x minus 3 all squared. And then that becomes, well, x minus x cancels, so that's 0. And then you've got minus 3 take away 5, which is minus 8 over x minus 3 all squared. And that's it for this example. Let's go to another example. And let's say that we have y is equal to e to the power of 2x over x to the power of 7. Okay, so we let u equal the numerator, e to the power of 2x, and then we let v equal x to the power of 7. We say du dx is equal to 2 times e to the power of 2x, so that's using chain rule, and we've got dv dx as 7x to the power of 6. So again, just to write out the quotient rule, which I would recommend writing, it's not just for the sake of being tedious or being boring or making you do it. We've got dy dx is equal to v multiplied by du dx, take away u multiplied by dv dx, all over v squared. Okay, and that becomes, well, v is x to the power of 7, multiplied by du dx, which is 2e to the 2x, and then take away u by dv dx, so that's e to the power of 2x, multiplied by dv dx, which is 7x to the power of 6, and that's all divided by v squared, which is x to the power of 7 squared. Okay, and again, at this stage, it is officially differentiated, but let us take it further and simplify. So we have 2x to the power of 7 e to the power of 2x minus 7e to the, maybe not like that actually. Let me do it like this. Let's do it like this. 7x to the power of 6, e to the power of 2x. That looks nicer. All divided by, or x to the power of 7 all squared is x to the power of 14, using those laws of indices. And then we can factorize x to the 6 and e to the 2x. Then we have 2x on the inside, take away 7. And that's all divided by x to the power of 14. But, we can also do x to the power of 6 divided by x to the power of 14, giving us e to the power of 2x. Let's make that x a bit clearer. E to the power of 2x multiplied by 2x minus 7, all divided by x to the power of 8. Okay, and that's it. Take care for now, guys.